Good evening. Today's quote is by Winston Churchill. The pessimist sees difficulty in every opportunity. The optimist sees opportunity in every difficulty. The pessimist sees difficulty in every opportunity. The optimist sees opportunity in every difficulty. Today's word is audacious, showing a willingness to take risks or offend people. He described the plan as ambitious and audacious. You have already done this part. Roots of quadratic equation ax square plus bx plus c equal to 0. In 10th standard, you said that a, b, c are strictly real numbers and a not equal to 0. Now, a, b, c can be complex numbers also, but yes, a should not be equal to 0. Okay. Now, can you tell me the formula for roots of this quadratic equation? It is x equal to minus b plus minus root of b square minus 4ac divided by 2a. Okay. Now this b square minus 4ac is called as discriminant and is denoted by delta. See, this is not determinant, discriminant. Now, in the beginning, we consider A, B, C as real numbers, A not equal to 0. Now, discriminant is clearly a real number. Why? Because A, B, C are real numbers. Many students take root B square minus 4AC as discriminant. No, B square minus 4AC is discriminant. As it is a real number, there are three possibilities. Number one, this discriminant is greater than 0. So in this case, roots are real and unequal, that is distinct. Okay. Second possibility, delta is 0. Roots are real and equal. Not only that, each root is minus b upon 2a. Why this is so? See the formula. Why two distinct roots? Because this is non-zero. Minus b plus this by 2a. Second minus b minus this by 2a. But if this is 0, then each root is minus b plus 0 by 2a minus b minus 0 by 2a. And that is why I am saying each root minus b upon 2a. Now third possibility, as delta is real, it is negative. So roots are not real, means they are complex, right? You will notice they are complex conjugates of each other. That is, roots are of which type? A plus IB and A minus IB. Okay. Now exercise 1, I think, yes, 1.2 seconds. Second sum, you have to write comparing given equation 2x square minus root 3x plus 1 equal to 0 with standard equation ax square plus bx plus c equal to 0 to get what? To get a equal to 2, b equal to minus root 3c equal to 1. Then discriminant delta is, now you may ask, is it necessary to find delta separately? Actually, it is not. You can directly write the formula and substitute the values. For that also you will get full marks, because we are asked to solve the quadratic equation. We are not asked to comment on the nature of the roots. Still, I have obtained delta minus 5. So roots are complex. Roots are given by, therefore, roots are x equal to minus b plus minus root of b square minus 4ac divided by 2a. Okay. Substitute. So this is minus of minus root 3. You have to be careful, because BE itself is minus. So minus of minus 3 plus minus root of minus 5 divided by 2a. What is a? A is nothing but 2. Now this is root 3 plus minus root 5 into root minus 1 divided by 4. So this is root 3, okay, plus minus root 5i divided by 4. You have to write answer separately. Write separate roots. Roots are root 3 plus root 5i upon 4 and root 3 minus root 5i upon 4. Write down. Now third one, compare 3x square minus 7x plus 5 equal to 0 with ax square plus bx plus c equal to 0 to get a equal to 3, b equal to minus 7, c equal to 5. So what are the roots? Minus b plus minus root b square minus 4ac upon 2a. B is minus 7, so minus b is 7. I have directly put value of b square. Simplify to get root of minus 11, which is root 11 into root minus 1, which is I. So the separate roots are 7 plus root 11i by 6, 7 minus root 11i upon 6. Third question, solve the following quadratic equations. Second, fourth for homework, I have given the answers. First one, compare x square plus 3ix, I is an imaginary unit, plus 10 equal to 0 with ax square plus bx plus c equal to 0 to get a equal to 1, b equal to 3i, c equal to 10. So it is root of b square minus 4ac. Substitute the values. B is 3i, so b square is 9i square, but I square is minus 1, so minus 9, this is minus 40. What is root of minus 49? Root 49 into root minus 1, that is 7i. Write the formula, substitute the values. So the roots are minus 3i plus minus 7i by 2. So minus 3i plus 7i by 2. And the other root minus 3i minus 7i upon 2. So simplify to get the first root as 2i and second root as minus 5i. For the third equation, x square plus 4ix minus 4 equal to 0, I have directly written. In exam, please do not write like this. You will lose 1 mark. You have to say comparing with, because what are ABC? You have to first mention values of ABC. So roots are, substitute the values, 16 I square is minus 1, so minus 16 plus 16, root 0 is 0. So you will notice that each root is what? Minus 2i. Question number 4. Solve the following quadratic equations. First one, please listen to me. Do not write the solution, but please do write the solution after the lecture, because this can also be asked in exam. Comparing x square minus 2 plus ix minus 1 minus 7i equal to 0 with ax square plus bx plus c equal to 0. We have a equal to 1, b equal to minus in bracket 2 plus I, c equal to minus in bracket 1 minus 7i. So find out b square minus 4ac separately. This is the standard practice. Replace I square by minus 1. So this comes out to be 7 minus 24i. So the given equation definitely has complex roots. These are given by what? Minus b plus minus root of b square minus 4ac upon 2a. Substitute the values. See why degree of difficulty is increased? Because this is altogether different sum. We have solved, in fact, we solved the same sum yesterday, but of course do not use that data. So solving or finding roots of a quadratic equation. So you have to write this separately. We have to find root 7 minus 24i. Let root 7 minus 24i be p plus qi, where p and q are real numbers. Square, same practice. Equate real and imaginary parts separately. So p square minus q square is 7 and twice pq is minus 24. So what is q? Minus 12 by p. Put this value in above equation. So p square minus, I hope you will not say minus minus plus. See the cursor. See, you have to find q square. Square of negative number is also positive. Remember. So p square minus square of minus 12 by p equal to 7. That is p square minus 144 by p square equal to 7, and so on. Multiply by p square. See, the same we have solved. P square is 16, p square is minus 9. Now p is a real number. So discard minus 9, consider 16. So p is plus minus 4. Now when p is 4, q is minus 3. And when p is minus 4, q is 3. So what are the roots? Plus minus 4 minus 3i. Now substitute these values in the formula. You have to be very careful. Do not find roots orally. You have to say roots are 2 plus I plus 4 minus 3i upon 2, and other root 2 plus I minus in bracket 4 minus 3i upon 2. Simplify to get two roots as 3 minus I and minus 1 plus 2i. Is it clear? It's a marathon sum, but will be asked for 4 marks. Second sum, compare given equation with standard equation to get a equal to 1, b equal to minus in bracket 3 root 2 plus 2i, c equal to 6 root 2i. Now find out b square minus 4ac. You have to be very careful. Square of minus is plus. So 18 plus 12 root 2i plus 4i square minus 24 root 2i. So 18 minus 12 root 2i, I square is minus 1, so minus 4. So effectively, b square minus 4ac is nothing but 14 minus 12 root 2i. Then you have to say roots are minus b plus minus root of b square minus 4ac upon 2a. Substitute the values. Now, this is altogether different sum. Roots of this. So we will find this separately. Once we obtain roots, we will put roots in 1 to get actual roots. Let root of 14 minus 12 root 2i be p plus I cube. P and q belong to R. Square. Then equate real part to real part. P square minus q square. See, this stands for what? On equating real and imaginary part separately. P square minus q square is 14. Twice pq is minus 12 root 2. So what is q? Minus 6 root 2 by p. Put this. I have directly put the value of q square. So p square minus, what is square of this? 36 root 2 square is 2. So 72 upon p square is 14. Multiply by p square. This is an equation. What are the roots? What are the factors rather? P square minus 18. P square plus 4 equal to 0. So p square is either 18, p square is minus 4. You have to discard minus 4. Why? Because square of a real number is never negative. Now p square is 18. So p is plus minus root 18. That is plus minus 3 root 2. Why? Because 18 is 9 into 2. Now when p is 3 root 2, q is minus 2. Q is minus 6 root 2 upon 3 root 2. And when p is minus 3 root 2, q is this. So what are the roots? Plus minus in bracket 3 root 2 minus 2i. So from 1, roots are x equal to 3 root 2, you have to be careful, plus 2i, okay, plus minus 3 root 2 minus 2i upon 2. You have to be careful. That is x equal to, first I will consider positive sign, 3 root 2 plus 2i plus 3 root 2 minus 2i upon 2, that is what? 3 root 2. Just check this. 3 root 2 and other root x equal to 3 root 2 plus 2i minus in bracket 3 root 2 minus 2i upon 2. So 3 root 2 plus 2i minus 3 root 2 plus 2i minus minus plus divided by 2. This is nothing but 4i upon 2, that is 2i. Okay. So we will write answer separately. You have to be very careful. Roots are how to check the answer. See, what do you mean by root? It is that value of x which satisfies the equation. Okay. Now, what do you mean by satisfies the equation? If you replace x by either 3 root 2 or 2i, then both sides will be equal in the equation. Right. Third sum is for homework and the answer is 3 minus 4i, 2 plus 3i. Fourth, what is the equation? 2 plus I x square minus 5 minus I x plus 2 1 minus I equal to 0. So these are the values of ABC. Find out b square minus 4ac. You have to be very careful while opening the brackets. You will notice that b square minus 4ac comes out to be minus 2i. So what are the roots? Substitute the values. Yes, so these are the roots. This is not the final answer, of course. We have to find root of minus 2i separately. Initially, we assume that roots are plus minus actually, or just say root minus 2i, p plus iq. Eventually, there are two roots. One is plus, other is minus of this. Actually, minus 2i means what? Just a minute. Minus 2i means what? 0 minus 2i. So, p square minus q square equal to 0. That is p square equal to q square. Okay. And twice pq minus 2. So, what is q? Minus 1 upon p. Now, put this in above. So, p square is 1 upon p square. So, p raised to 4 is 1 So p square is 1, but I have to mention as p square cannot be minus 1. Reason, p is a real number. I hope you are getting this. See, p square equal to 4, p raised to 4 is 1, means p square is 1 or p square is minus 1. But how can p square be minus 1 if p is real? It cannot be. So we consider p square equal to 1. Okay. So what is p then? So p is plus minus 1. Now when p is 1, q is minus 1. When p is minus 1, q is minus 1 upon minus 1, that is 1. So you should know this, q is minus 1 upon p, right? Therefore, what are the roots? Roots are 1 minus I minus 1 plus I, that is plus minus 1 minus I. You can also check this. If you square 1 minus I, see whether you get minus 2I or not. So from 1, what is x? 5 minus I plus minus 1 minus I upon 4 plus 2I. So first root is, I will consider positive sign in between. 5 minus I plus 1 minus I upon 4 plus 2I. So it is 3 minus I upon 2 plus I. You are not supposed to write this as the final answer, because to divide 3 minus I upon 2 plus I means to multiply numerator and denominator by a complex conjugate of denominator, which is 2 minus I. Okay, simplify. So what is the first root? It comes out to be 1 minus I. Find out second. So x equal to 5 minus I minus 1 minus I, denominator as it is 4 plus 2I. So this is 5 minus I minus 1 plus I upon 4 plus 2I. So this is 4 upon 4 plus 2I, that is nothing but 2 upon 2 plus I. Is this the final answer? No. You have to multiply it by conjugate of denominator, which is 2 minus I. So 2 into 2 minus I upon 4 minus I square. So this is 4 plus 1. So this is 2 into 2 minus I upon 5. So how do we write this? 4 upon 5 minus 2 upon 5I. So last step, I will say answer. Roots are, how to verify the answer. See whether these values satisfy the equation or not. At least you can verify for the first. So 1 minus I, and second one is what? 4 upon 5 minus 2 upon 5I. Okay. So that's it for today.